All right, so in that last video, I made a bit of an error. I don't know if you caught it. Actually, it wasn't really an error, but I violated our rule of sorts that we established of putting, code in its own particular method, that handles a certain process and has a kind of a single responsibility. In particularly referring to the enemy proximity method that we created that housed the calculating the distance between the cube and the sphere. But unwittingly, in the very same method, we also stored the code for moving the sphere towards the cube, right? So this is a movement method. This script, even though it's 2 lines of code, it probably should go in its own method. So let's quickly refactor that and put it in its own method here for the sphere controller, just like we did for the cube controller. So take that out of the enemy proximity method and then put it in private void movement. So this is the movement method specific for the sphere controller, right? And then call it here. Build it. Oh, we already got an error. What's our error? Cube ref position does not exist in the current context. Right? Remember we took cube ref position from a field, a class level variable. We made it local to the enemy proximity method. Well, see, that's not going to suffice any longer because now we have 2 methods that need to reference this variable. So we pretty much have to go back to, the easiest thing to do is put it back into a field of its own, because now it needs to be kept alive in between each method's call, right? So let's do exactly that. Let's put it as a field back up here. And remember our naming convention that we were going to follow, uppercase Pascal case convention for fields and lowercase camel case convention for local variables. So this is no longer a local variable. I'm going to do these all manually here. There we go. Oh, and we need to remove that so that it's only declared once. That solves that. But what we could have put as a local variable in using much the same logic was the distance field here. We could just make that into a local variable. And it was only public because we wanted to see its value in the inspector for a brief period of time. So that's not really relevant. So we can just go vector2 distance right there. And that works just fine. Now, I guess this is a good chance to explain constructors. In the last video, I kind of left the idea hanging, and I gave you sort of an example of how a constructor could be used, either in a struct or an object when setting it, right? When you first set it as a variable, you have the chance or the option to invoke the constructor, and structs and objects both have constructors. Well, what is a constructor exactly? We could, invoke a constructor here. We don't have to because it's a struct, but nonetheless, what is a constructor? So constructors are really simple to understand. Basically, they are methods that either for a struct or an object are named the exact same name as the struct or object, the type, in other words, the class or struct type. And when you create a new version of that struct or object, you can run this constructor, and that constructor, when it runs, is meant to put that object or struct into some sort of valid initial state. So it's like an initialization or construction method, right? That's particular to the type in question. So again, structs do not require a constructor, right? You don't see the new keyword followed by new vector2 unless you want to, so it's an option. But again, because it's a value type, as I mentioned in the previous video. But with objects, you're required to run the constructor right at instantiation, right after the new keyword, right? We've always seen this, the wizard equals new wizard with the empty parentheses. Or, of course, you could put something in those parentheses if there's input parameters available. So let's look a little closer at constructors. Let's look at even though it's a struct, we can still look at constructors for vector 2. And there you go, there's a constructor right here. Constructs a new vector with given x, y components. That's that constructor right there. And, well, that's not very instructive. So what we'll do actually is we'll make our own constructor. So let's go back to our test right here, RPG controller, RPG classes. Right here in the, how about the weapon class, right? Weapon class, it doesn't actually have a constructor yet, right? So how do we run this method when we say weapon equals new weapon? How do we even run that method? It doesn't exist in the weapon class that we created. Well, actually it does exist. It just gets automatically created, an empty constructor in this case. That's why there's empty parentheses. There's nothing in the, as an input parameter, there's no implementation details either. So, but here we can create our own constructor if we want. So simply say public weapon has to be the same name, parentheses, and we'll put something in there if we wish. And now we can set its fields, for example, to some sort of values. So that might be a good idea to put it in some immediate valid state right at instantiation, because you could get some sort of weird errors if you don't do it right when you instantiate it in memory. So that's why constructors are particularly useful. And actually, I'm just, for the sake of visual appeal, I'm going to put the constructor right above the first actual method. As you see, a constructor doesn't have a return type because it doesn't return anything. It's meant to just modify the values predominantly of the fields and properties of that class. So here we have two class fields, and so we can say, how about we can pass in a string, and let's say lowercase weapon type, following our naming convention rules. And how about int degradation, again, as we local to this method, sort of as we did in the deflect method. And what we'll do is we will use this constructor to set this weapon type, which refers to whatever object is created, whatever instance. There's going to be maybe several instances of this, so it's going to refer to this weapon type, the class level instance field is going to equal whatever we pass in here as weapon type in the constructor, right? And this uppercase D degradation, I don't know if I mentioned too much about this keyword. It's totally optional. In this case, it's actually not required at all because I'm differentiating the variables uppercase for the field, lowercase for the local scoped input parameter. But nonetheless, I try to be in the habit of using the this keyword in these kinds of exact usages because it just makes it that much more apparent when glancing at the code what's going on. So I'll reference the lowercase d degradation, right? And take that out because we're no longer needing to initialize it to a consistent state of 100. We can pass in whatever degradation value we want it to hold at instantiation. So as you see here, now it's got an error because it expects there to be a constructor with two input parameters. So now this wasn't too well thought out because we want to have each combatant have its own kind of weapon. So I don't really want to get too much into that because we're not going to use this code in our actual project. So, and I just want to focus on constructors right now. So bear in mind this is going to be not really useful, but it will still illustrate how constructors are used. So we can pass in here for combatant a weapon type. Let's say, again, sword as we did before, and degradation 100. So again, if you're creating a game, this is definitely not going to be the right way to do it. You probably want to have a constructor for the combatant, and then have the combatant take in, say, a weapon, and create that object elsewhere, put it into the combatant's constructor, and so on. Anyways, it doesn't matter because we're not using this code, and actually we'll just revert to the way it was previously, because it's going to ruin our references with. It's going to kind of screw up how we set things in the RPG controller. I mean, we actually effectively overrode what the weapon was holding, right? So it doesn't actually ruin the references, but actually let's give it a default, just say rusty sword there, just for creativity's sake, and we'll leave that. Okay, so that's the constructor for the weapon. Now, going back to the vector 2 distance here, we have the option of running the constructor, right? As I said, with a object, you need to run the constructor, even if it's empty. But with a value type, like an int, vector 2, any kind of struct, it immediately gets set in memory with, either nothing, or it just sets out that memory space, or whatever you assign at that declaration of that, declaring that variable and the variable type. So right now we could use the constructor if we want for distance, and kind of rework this a bit. So what do we have available to us? I have to say new vector 2, right, to access the constructor. So we can put in x, y as floats, because, well, we have either an empty constructor or specify the x and y properties, right, as input arguments to the constructor. So sure, why not? Let's just do this a little bit differently and use the constructor. So here, I already wrote this out. Just copy and paste it. So basically copying this right here, but as before with the vector 3, just put them in floats, and in the constructor reference that x and y, right? I don't like that space. I'm gonna take it out. And oh yeah, never did fix this, did we? Right? This has to be uppercase C, and build it. Awesome. So there we go. A lot cleaner, I think, this code. Now, one other thing I want to quickly mention about this local variable, choosing to create a locally scoped distance variable, which again, later, just like we did with the cube ref position field, we decide to make that local. We might decide to make this distance local variable into a field again, right? But there's another consideration. So when you make it locally scoped, right, it gets created and destroyed each time that method is run, right? It gets rewritten over and over again in memory. It's basically like the memory space is being allocated and then erased, presumably. I mean, I'm not sure exactly how memory management works in C#. It's something called a garbage collector, so it automatically gets destroyed when there's no longer any use of that throughout the code. The garbage collector just automatically gets rid of that memory allocation for that variable if it's no longer used. So presumably with this, let's say, enemy proximity method, in the update method, updates running again, if it's 60 frames per second, it's running 60 times a second. So presumably this distance variable is being created and destroyed 60 times a second. So that might seem exceedingly injudicious to performance and to keeping things nice and clean and tidy in memory, right? Because it just seems like an extra process that's unnecessary. So, I mean, in this case, we could have left it as a field, like a private field or whatnot, and it would have been probably maybe even a better choice, but I don't really care. Honestly, I'm trying to keep things as clean and separate as possible, keep my fields as few as possible as necessary. And to put it simply, this game that we're creating is not going to be pushing anybody's machine's performance boundaries, all right? And if it is, you know, I'm sorry to say, maybe it's time to upgrade, all right? But yeah, so I'm not going to worry too much about it in this case. There's always going to be some cases where performance really does matter, and you want to sort of squeeze out every CPU cycle and every little bit of memory usage as you can, but it doesn't really matter. It's pretty negligible. So that's about it for this lesson. We'll go into a lot more coding with our game project in the next lesson. See you there.